So continuing on our 6-4 path, polar equations. Here's a polar equations. R equals the site. That's in the video for crying out loud. I know. Okay. R equals 4 cosine theta can be converted into a rectangular form as follows. I wanted to walk you through the process. There are some important things. I believe I showed it in a previous video that you need to know how to substitute, and these are those important things. You need to know that you can replace r cosine theta with x. You need to know that you can replace r sine theta with y. You need to know that you can replace r squared with x squared plus y squared. And that tangent theta equals y over x. These are important things that you're going to need to be able to use for substitution purposes. Yes. So, wait a second, it's in the notes. It's already in the notes. This is called review. Well, if it's not in your notebook, why is that not there? Okay, you're going to have to take your laptop. Yeah, there you go. Take a picture of it with your laptop. Notice what they did in the very first step. This is something that you would have, there would be a little bit of creativity on your part. They multiplied both sides by r. Now, what you're about to ask me is, why, Mr. Steve? Why did they do that? Okay? I do understand that you're about to ask me that question, alright? Because of that right there. What can you replace with r cosine theta? Please look at that blue box. This is plain old x. What are we replacing with r squared with? What are we going to change that to? X squared plus y squared. Remember, the whole goal is to get it into what we call rectangular form. Rectangular form. We multiplied both sides by r so that we could make this substitution. Now, that's not completely the way we should leave it. We should push this term to the other side, giving us x squared plus y squared minus 4x equals 0. That's typically how you would see that particular rectangular equation listed out. Now, could we go further and do some completing square stuff? Sure we could. I'm going to look just ahead to see what form they put it in. Look in their book and see what form they actually left it in. They did complete the square. Alright, you can do that. You guys need to practice anyway. Okay, so to complete the square, we want to group the x's together. And notice that I'm leaving some empty space, and we've got the y's over here by themselves. Okay? Now, and you'll see here in a minute why they're completing the square. How to complete the square? Oh my goodness. Now, in my world, which is different than some of the other Algebra 2 teachers, I added this particular fraction to both sides of the equation. A lot of Algebra 2 teachers like to do the whole thing where they take the middle value, cut it in half, and square it. Now, for those of you that are paying attention, some of you are going to say, isn't that the same thing? Well, it is the same thing if the value of A is a 1. Can you tell me what the value of A is right now? It is a 1. So, in effect, this method is exactly the same whether you use the one that most Algebra 2 teachers will give you, which is that one, or the one I use. Now, the reason I use the other one is because if the A value is something other than 1, I'm okay. I see a lot of kids who make mistakes in the other direction when they use the other one. But we talk about that at different times. Since the A value is 1, it really doesn't matter. So what do you get in either situation? 17. Okay. B, well, looks like it's a -4. So what do you get in either situation? 4? Okay. So whether you use the b squared over 4 times a, or you use the b over 2 quantity squared, you're still getting 4. Well, if you have an a value that's other than 1, it actually does make it nicer, and someday in your future I will show you why. Okay, so you need to be able to factor this. What does that factor into? Why did I do what? If you add 4 to one side, you better add it to the other, otherwise you've upset the balance of the equation. Okay? The universe as well, yes. I agree with you wholeheartedly. Okay? What does that factor into in the red circled area? X minus 2. Now, we could say x minus 2 times x minus 2, but if we were, if we were super cool, what else could we say besides x minus 2 times x minus 2? Oh, yeah, x minus 2 quantity squared. Okay? Yeah, you want to say quantity squared at a party, otherwise they'll just make fun of you. Okay? And so on the end here, I've got a 4. Now, the reason that we like to complete the square is so that you know the center of this circle. Yes, folks, it's a circle. What's the center of the circle? Don't say the middle. It's not to look at it. You can tell what the center is. I'm touching this back in geometry. I don't care. You're supposed to know this stuff. Look inside here and tell me what the x part is. 2, right? It's been shifted to the right 2 units. Right? And then what's happened inside here before it got squared? Nothing. You were testing me. Nice. Okay, what was your question? This is what I envisioned. What is y minus 0? Y minus 0. Just tell me what y minus 0 is. Y. That's y. So, these two things are exactly the same, therefore, that's how you get the second part of that center. Anytime that nothing is being subtracted or added before the square, that means it's a 0. Okay? And what's the radius? Nope. Better look over here. You better not tell me 4. Exactly. Remember? A squared, it's a squared plus b squared equals c squared. Right? The form of a circle is the Pythagorean theorem. Yes. Right, the triangle is inside the circle. Remember this whole trigonometry thing about triangles and circles? Okay. Okay, so now we're going to practice converting from polar form to rectangular form. The first step has been given to you. Alright? The first step has been given to you. They said, let's divide by secant theta. Okay? Now, no. No, but you remember that whole, cell mitosis thing? Okay? Well, what if I split this up into this? Nice. You going blind? Just because of that? In a welding helmet or something? Okay. Now think about what you can do with this. Change it to what? Cosine theta. That's right, because remember that cosine and secant are reciprocal functions. So if you take 1 over secant, you've got cosine. So this is our slight mathematical dab. She must have said that answer as well. Nice. Nice. R cosine theta equals 4. Finish this problem. What can you replace this with? Folks, what kind of graph does this have? It's a line. What kind of line? Vertical line, thank you very much. Okay. Okay. Shall be performing points. Okay. All right. I'll show you. Like horizontal lines. I was expecting things like straight line. Of course, all the lines are straight, so I never can figure out that one. But nice job. Converting from rectangular form back to polar form. Okay? I would suggest that you do a little bit of foil, folks. Okay? Go for it. Foil. You're going to have to foil not only the x's, but the y's also. Go. Because I said so. Okay? Yeah, sorry to the folks at home. All of my 40 YouTube fans. Oh, that is so nice. Shout out to Crosscom. Alright. Okay. Alright, now. If I push the 13 over to the other side, what happens? Oh, yeah, we got some bye-bye. Look at that. X squared plus y squared minus 6x minus 4y equals 0. Okay, okay, now, that is a great point that he brings up. He said he kept his x's and his y's together. Now, I'm showing you the reason I rearranged these. I have a particular reason that I did that. Okay? I need you to focus your attention here and tell me what you're going to replace that with. R squared. Remember, we're trying to change this into polar form, so we've got to use those substitution tools the opposite direction. Okay, now what are you going to replace that x with? R cosine theta. Because that would be y. Grab my arm. Okay. Is there anything that you can factor out of all three terms? R. Yes, definitely. Let's go. Okay. That sounds exactly how Arnold Schwarzenegger sees. Doesn't it? Yeah, it sounds exactly like it. Okay. Okay, folks. We've got it in factored form. I know that's ugly looking factored form, but we have it in factored form. How do you go from here? When you get it into factored form, how do you find out? See, it says something times something equals 0. What do you know about one of those factors? I do realize, folks, that one of the factors is this one over here, and the other one is this giant mess. Okay, but what do you know about one of those factors? It equals 0. So either r is equal to 0, or r minus 6 cosine theta minus 4 sine theta equals 0. What do you think r equals 0 looks like? Oh, close. What does the graph of r equals 0 look like? How do you think? It's a dot. It's a dot at the center. It is at the origin. Okay? Well, if the radius of the circle is 0, that's a pretty small circle. Yeah, right. It's actually a point on the edge. Now, what do you have over here? We have r, let's lock it in place. We have r equals, if I move these two terms to the other side, I get r equals, and I should probably erase that so it's not in my way, 6 cosine theta plus 4 sine theta. Do me a favor, grab your graphing calculator. Okay? Grab your graphing calculator. We will need radian mode. Alright, it's a good question. We will need radian mode. Make sure your calculator is set to radian. So make sure it's switched to radian mode. Everybody got it to radian mode? Okay. Next, we go down to the next one, and we do not want parametric mode. What mode do we want? Polar. Polar. I've never used this much. I don't know. I'd have to check. Okay. No. Okay, so everybody got it in polar mode. Now go back to your y equals. See, instead of having y equals or xt and yt like we do with the parametric mode, we have polar mode. Okay, so what do we want to type in here? 6 cosine theta. Theta is that button that's diagonal from your second button, xt theta n. This time, when you press that button, it won't give you an x or a t, it'll give you a theta. I know. Okay, and then 4 sine theta. And then you can graph that. Please graph it. Oh my. I bet my window's really messed up. Okay, folks. Did you get a something that looked like this? Okay. Yeah, you don't want an equal plot on at the same time. Okay, you can't take pictures with that. Oh, okay. Someday. Alright, now. Go to Zoom. Please, everybody go to Zoom. I said no. Okay. Go to number 5. Go to number 5. Zoom square. See, the reason that you, and then see if there's a difference in your graph. Okay, folks, you had a circle. That's what you were dealing with. Now, you didn't know that from the original graph that you had because every one of the blocks on the screen was a rectangle. the original graph is a rectangular set of groups, and it kind of swooshes it. That's why the circle didn't look like a circle. But when I change the blocks to square, then you can see that it is a circle. What? Flounder. That's what you did. Okay, but I'm glad you have it. Now, does that particular circle go through the origin? So remember we said r equals 0 is one of the factors? The origin is actually on that circle. Okay? Now, what is the radius of that circle? I'm gonna say that you're probably going to know the answer better. You're going to probably know the answer better if you go back below that. Alright, now, go back to the original rectangular form of this. Can you guys tell me the center of the circle? What's the center? Okay, 3, 2, right? Yeah, you guys did learn. That's awesome. I like it. Okay, what's the radius? Something to do with this. Yeah, how'd you get that? No, not divided by 2. I know what you did. You used the last example about b divided by 2, but we didn't. Because remember, it's a squared plus b squared equals c squared. No, it's not. We're not dividing by 2. What do we do with that 13? Oh, square root. Higher. It's a math song. I heard it at a party. Every night after work, you guys leave. This place is a madhouse. I have to clean it up every night. They don't even get in the door. Are you kidding me? They're too busy deciding when the door has feelings. It's usually about 16 answers. Here, there's only one. Okay. Example 8. Radar detects 2 airplanes at the same altitude. Their polar coordinates are 8 miles, 110 degrees, and 5 miles, 15 degrees. This is not on the bearing scale. This is the direction scale. So it's based on your unit circle. How far apart are the planes? Okay, I'll zoom in on the picture so you can see. So they gave me 2 polar coordinates. They want to know how far apart these planes are. Okay, I'll pause the video and I'm gonna. So since you were speaking of the needed hint, it's a triangle. I didn't know if you knew that. Can you tell me what this angle is down here? That is not 90. I would say that's about 90 plus 110. Okay, isn't it 110 take away 15? 95. Yeah, I forgot to carry the 1. Alright, now. Do you know any of the sides of this triangle? Oh, we know the magnitude of that and the magnitude of that, right? Because polar form tells me the length of that, the radius. That's the hint I'm giving you, and now you need to do it yourself. We can't do SOHCAHTOA because it's not a 90-degree right triangle here. Law of cosines? We always tried to use the law of sines first, but I don't see a known angle and a known opposite side, so I think you're right. I think we do have to use the law of cosines. Nice job. All right. Okay, do it. Time's running out of room. What doesn't make sense? Right, you're supposed to fill them in. Oh, okay. Yeah. Good like that. Yes. The first space would be a side. Remember we talked about how the greatest decision you have goes in those two blanks. They are on opposite sides of the triangle from each other. One of them is an angle, one of them is a side. Well, if I were you, I'd focus your attention here. The angle is a capital letter. Oh, okay. But remember, cosine should be in the end. The angle had to go there. The side would have to go on the right side. Oh, okay. So hopefully you decided that it would be cosine 95. You do have to be in degree mode because we have a 95-degree angle we're working with. You're welcome. Hey, man, it's good practice. Yeah, you do. Cracking me up. The law of cosines?
Yeah. I don't know it. I really don't.
You should learn it. I don't know. Yeah. Do we have everything on the right side of the equal sign, yes or no?
Yeah.
Could we just type all the stuff in on the right side and hit the enter button? Okay, and then what? Take a square root. See, this was the easy version of the law of cosine, right? Really? Did you get your mode in degree? I don't know. 5 squared plus 8 squared. Minus 2 times 5. What's wrong? It's a necklace. Somebody blinged out my Tommy cat.
Can I try it on?
Yeah, you have this question done.
Yeah, I do. I got 9.8.
Okay.
That's right.
Square root. 9.8. Okay.